do.
So when you've got everybody's attention, you can go ahead and begin.
Sarah, I'd like to thank you for making this meeting possible with Google. Google has a reputation of building a great company using the conventional communication techniques in data communications. And then came along streaming and high-resolution imaging and a deeper embracing of your technology on the internet that's driving a larger and larger data demand capacity. New modulation scheme has come along called PAM4. You're engaging in developing your data capacity around that technology. Have you considered how these three numbers represent a threat to your success? Okay. Number two, in PAM4, PAM2 drives at least twice the bandwidth speed that you've conventionally dealt with in the past. The interface systems have at least twice the signal loss. So we have twice the bandwidth, twice the loss at a minimum, which is going to challenge you on signal integrity, de-embedding, noise floors, to be able to look at the performance of your data communication scheme. 28. In equivalent time or real time, clock recovery greater than 28 gig becomes either a technical challenge or a very large economical challenge. The real-time world gives you an opportunity to efficiently address this. 31. If you're developing PAM4 devices, this is probably one of the most challenging specifications you're going to have to verify. This is 31 dB or less of SNDRQ. That means your measurement system is going to have noise performance that's greater than 31 dB to be able to enable you to make that verification. So with that, I'd like to turn it over to my colleague Luan and let her give you a deeper view of what the real-time environment versus your existing equivalent time environment might look and how you might benefit from it.
So you may wonder what those three numbers mean to you. So why should you care? We're going to look at starting with 28 gigabyte. This is you here. You're starting your testing. Go out here at 28 gig. You have to collect some amount of data, some amount of information, and you have to do it in a certain amount of time. At some point, you're going to have to come out to 56 gigs. You're going to need more information, more measurements. You're going to have to address SNDR. And you have more measurements, SDNDR. And you're going to have to figure out how you're going to do a clock recovery at 56 gig. So why is this still important to you? Because you need to make a transition from sampling scopes to real-time scopes. So I'm going to take it to Dave to give him a story about why that needs to happen.
You know, Google, in preparation for this meeting, Tektronix hired Forrester Research to go off and actually look at the two different domains here, of which Lon pointed out. One was the using of sampling scopes, which is your traditional method of what you're using today, and how long it's taking you to be able to measure your current PAM4 systems. And what they looked at in the market is that it takes traditionally about 3 days in order for companies using traditional sampling systems to measure PAM4. Forrester also came back and looked then at real time and concluded that you can take and reduce that time as much as 4 times of what it currently takes for you to be able to test using your current sampling systems. Forrester also concluded that if Google goes down this path and continues down this path, they should seriously consider restructuring and sale of the company. If they were to go down the real-time path, we guarantee that the future success of Google is going to be far superior because their products are going to be able to get out to market sooner. Thank you.
Pretty compelling, huh?